And of course, the test is next week, Wednesday already. Last test of the year. So here's the assignment sheet. So look how easy this is. Tonight's homework. This is BC full. I think tonight's homework here. Here's tonight's homework. You know what? I'm not gonna even show that homework. Let's just go to the thing. Why did I even erase this? Oh gosh. Surface area, mass of a material surface, we did that already. Here, the divergence theorem. So the last two things we're gonna learn are to compute divergence and curl. And then we're gonna watch a video on what exactly divergence and curl is. These are all physics applications. It has to do with flux. You guys ever familiar with flux? So like, this is what I understand it to be. Divergence is, even though I don't really understand flux that much, divergence is like flux per unit volume. Is that, since you guys are better at physics than me, do you guys understand that?
What is flux?
Flux is like how something flows through a material, right? Like water flowing through a filter or something. Well, that's why we're gonna watch the video. So all you have to do for tonight's homework is compute divergence, and then we're gonna watch a video on what divergence actually is. And curl. So, look, if you look at your book, we are on page, what page is this? Oh gosh, I have to go back and scroll. If you're following on the video, we are on page 851. So if you have a vector field, you're given a vector field, or it could be like any kind of force field, magnetic field, or whatever. To compute the divergence of this vector field here, look what it says. Take the partial of v1 with respect to x, plus the partial of v2 with respect to y, plus the partial of v3 with respect to x. And in a two-dimensional setting, then of course it would just be this, then right there, yeah. Three-dimensional, two-dimensional. Those are the two things they give you on page 851. So look how easy this is. It's super easy to compute it, but to understand what it is, that's a whole nother animal. Okay, so look at your homework. So I think tonight's homework, you only have to do problems 1, 3, 4, and 6.
Mr. Bart,
Yeah.
are
So,
V1, V2, and V3 different?
yeah, those are the components of the vector function, the vector field.
Also, V1 is the x component.
Yeah, exactly. So let's do number 2. In fact, let's do the 2 unstart problems, and you can do the 4 start problems for homework. So here's your vector field. I'm going to write it like this, negative x. So it says compute the divergence. Well, the divergence of this vector field here, this one here is, so in the two-dimensional setting, then you're just going to do this, yeah, like that. So this is v1, and that's v2. So what's the partial of this with respect to x?
0.
Plus, what's the partial of this with respect to y?
0.
You get 0. That's kind of boring. Okay, let's do number 4 now. Now we have a three-dimensional vector field, so we got x, y, z, x, z, and z. So now we're going to do the three-dimensional one that looks like this. So to compute the divergence of this vector field, you take the partial of this with respect to x,
YZ.
yz, plus the partial of this with respect to y, 0. And then the partial of that with respect to z, that's a z there, by the way. 1, there you go, that's the divergence. Well, what does this thing give you? What is the divergence of a vector field? Well, it's like the flux per unit volume. Okay, so we're gonna watch a video that shows that. So I gave you the link to the video. That's pretty much that's the end of the lesson right there. All you have to do is compute it. It's really easy.